Yes, as we already seen that there are the two forms of mechanical energy, kinetic energy and potential energy. Now we are going to study about kinetic energy in detail. Then what is kinetic energy? The kinetic energy is a energy possessed by a body by virtue of its motion. So whenever the body is in motion, at the time the body possesses some energy. That energy is called as a kinetic energy. Kinetic means movement. So that energy is called as a kinetic energy. Expression for kinetic energy. Very simple, students. Let us take a body of mass m. It has a mass m. Okay, when the applied force F is applied on it, so the initial velocity, the body is initially at rest. The body is initially at rest. So the velocity is called as a initial velocity u. Here the u is equal to 0. So when the body is initially at rest, so we can say that the initial velocity of the body u is equal to 0. When the force F is applied on the body is moved from the point A to point B. So it displays to the distance of S, that is the displacement is S. It moves with the acceleration A. The final velocity of the body at this point B is V. So we can use the formula Newton's equations of motion. V squared minus U squared is equal to 2AS. So final velocity is V and initial velocity is 0, then 2AS. Then what is the A? We have to bring 2S here. So the acceleration of the body during this motion is V squared by 2s. Then what is that? Kinetic energy we have to calculate. So energy means work. If you calculate the work, that work is equal to kinetic energy of the body. That is, work is equal to force into displacement. Here the force is ma, here the force is ma and s. Instead of acceleration, already we have calculated that a is equal to v squared by 2s. Substitute here. So this s and this s get cancelled. Finally we get work is equal to half mv squared. As the work appears here is stored as a kinetic energy. That is, the work done appears as a kinetic energy of the body. So kinetic energy is equal to half mv squared. So very simple derivation. By this derivation only we get that kinetic energy is equal to half mv squared. Initially we take the body is at rest. Initial velocity 0, final velocity v. So it will move with the acceleration a. Displacement is s. Simply we substitute the Newton's equations of motion v squared minus u squared is equal to 2as. Finally, we arrive the equation a is equal to v squared by 2s. Substitute this acceleration in w is equal to f into s. In this we have a acceleration. Substitute that value, we get an answer. Kinetic energy is equal to half mv squared. Then the same method, the half mv squared, whether it is possible to calculate by using the calculus method. So calculus method means I will say that the work done by the variable force. Okay, so that's a work done which is equal to force into displacement, that it is a dot product f ds cos theta. So the force is applied in this, make an angle theta with the horizontal or with the displacement. So the what is this theta means? Angle between force and displacement. The displacement is in this direction, force is in this direction, this angle is theta degree. Okay, so then w is equal to f ds cos 0 degree. How it is 0 degree? Because f cos theta direction and s direction, both the directions are parallel. So theta is equal to 0, cos 0 1, we get f ds alone. According to Newton's second law, f is equal to ma. So a is equal to rate of change of velocity. The rate of change of velocity means dv by dt. So work done which is equal to force into displacement. You substitute this m into dv by dt here. So m into dv by dt into ds. So ds by dt into dv. What is the rate of change of displacement? Yes, it is a velocity. So work done, small work done which is equal to mass into velocity into dv. So what is the variable force? So if it is a variable force means it is always changing, or by using the calculus method means it is a small work done. For the total work done we have to integrate both sides. By integrating we get the total work done which is equal to integration of dw which is equal to integration of mv dv. So how sir uv? The initial velocity is u, final velocity is v. Here the initial velocity is 0 because it starts from rest. So after moving it has a final velocity v. So in the lower limit is initial velocity, upper limit is final velocity. So w which is equal to m into integral lower velocity 0 v v dv. So this is similar to integral x power n into dx. So x power n plus 1 by n plus 1. So integral of v into dv, we are going to integrate the v with respect to velocity. So v squared by 2, that is v 1 plus 1 by 1 plus 1, v squared by 2. So we get that instead of integration of dv by v into dv, v squared by 2, the limit as it is 0 to v. Okay, so what is the upper limit? You have to substitute this v here. So m v squared by 2. Then minus lower limit, it is 0. So simply we get w, which is equal to half mv squared. Listen students, don't confuse. You should again take the previous videos what we are seeing in the 4th unit, the integration video. If you take the integration video, recall yourself. Very simple integration and integrating with the polynomial. That means x power n into dx is equal to x power n plus 1 by n plus 1. So the v will become v squared by 2. Substituting the upper limit minus lower limit, we get an answer half mv squared. Similarly, the work will be appears as a kinetic energy. Then the kinetic energy which is equal to half mv squared. So we have derived the expression for kinetic energy for the constant force, okay, or the normal Newton's equation derivation, and also we have derived the kinetic energy expression in terms of calculus method or the variable force. Both the answers are same, half mv squared, half mv squared. Relation between kinetic energy and linear momentum. So we already know that momentum, which is equal to mass into velocity, kinetic energy k is equal to half mv squared. Multiply m on both sides, that is or simple, we can do that similar way. So 1 by 2m, here the multiply by m and divided by m. So here m into m squared, here divided by m means 2m. So this equation never changes, m get cancelled, half mv squared we get. So m squared v squared means p squared, because p squared is equal to m squared into v squared. So we can write p squared by 2m. K is equal to p squared by 2m is the kinetic energy of the body, represents in terms of momentum, or p is equal to 2m come here, then we take the root, p is equal to root of 2m kinetic energy. So this is a relation between kinetic energy and the linear momentum of the body. Yes, I will show you the page. So we are seeing about what is kinetic energy, expressions for the kinetic energy in both constant force and variable force. Thank you students.